9.
No, never mind.
Number 9.
Number
Let's see what
9.
else. And number 9. Okay? So let's look at number 3.
Yes.
You were to find the vertical asymptotes, horizontal asymptotes, and the limit. Okay? Starting with the vertical. Before you can do the vertical, what do you have to make sure of?
Oh, there's a hole.
If there are any holes. And how do you know if there are any holes in the graph? How do you know if there are any holes in the graph?
Let me look at my notes.
How do you know if there are any holes in the graph? She's not the only one that can look. All y'all have notes on it. Come on, let's see what we have. If something divides out, and what is that something? It's a common factor. It is a common factor. The thing is, the numerator. Can we factor it? Okay? Can't really factor that. So then will something divide out?
No.
If it's not going to factor, can you divide out? No, it won't. So you don't have to worry about that part in this instance because the numerator wasn't factored.
So there's no hole.
There's no hole. So now we can go to our vertical asymptote part. And how do we find vertical asymptotes?
Over 0.
Say what?
Equals 0.
Denominator equals to 0. The denominator. So I'm going to rewrite just the denominator because I know sometimes you all have a habit of doing this. I'll tell you why I don't like that. Because it makes it seem like the whole thing is equal to 0. So I want you to write the denominator by itself and then set it equal to 0. Yes, ma'am. Yes, sir.
When you find the, you know how you don't find the vertical asymptote, you don't factor it out?
Yes, I do. Got to get
That's where I
there,
got
though.
confused.
You are going to have to factor because it is a quadratic. You got to set it equal to 0, and in this case, to solve that, factoring is necessary. So let's see. To get x squared, what do the first two terms have to be?
X.
X and x. To get a 2, what multiplies to give you 2? 2 and 1.
Negative something.
Now let's see. We know one has to be positive, and one of them has to be negative.
Positive 2, negative 1.
Well, let's see. Let's check it and see. I'm going to try it positive first and then do a negative. When you multiply the outsides, what do you get? X times a negative 1.
X.
That's a negative 1x, right? Multiply the inside, what do you get?
2x.
Positive 2x. When you combine negative 1x plus 2x, what do you get?
X.
A positive 1x, right? Is that your middle term?
No.
That meant the order needs to be switched. Order needs to be switched. Always go back and check it. Is that the problem? No, that's not. Okay. So instead of a plus 2, we're going to have a minus 2 and plus 1. Always check your outer and inner terms to see if you get the middle. Set them both equal to 0, each one. So you got x minus 2 equal to 0, or x plus 1 could have equal to 0. And what do you get for this one? X equals?
2,
And here x equals? And these are your vertical asymptotes. It has to be the x equals because it is a vertical line. It is a vertical line. Tap him again.
It's a vertical
Tap him
line.
again. Thank you. Stay with me. Stay with me. All right. So we have done part A. Again, to find the horizontal asymptotes, in order to do that, we've got to do part C, because to find horizontal asymptotes, you need to check the end behavior. The limit as x goes to either positive or negative infinity. That's right, end behavior. That's what you need to remember, horizontal asymptote. You got to remember to do that, end behavior.
I remember
But how do you use that? That's a process, remember? That's a process to help you find out what's going on with the end behavior. You can't do the Bobo Betsy Botany if you don't have a limit as x goes to infinity. Okay, that's the only way you can use it. So you got to do that limit. So we are doing a limit as x goes to infinity of this function f of x. So since we are doing a limit to infinity, we can do that process, the Bobo Betsy Botany process. You say they both equal, what are they? The highest exponent, or the degree. Okay? It's not that you were wrong, I just want you to use the correct math terminology. The degree of the numerator and the denominator are equal. So, what do you use when the degrees are equal of the numerator? The coefficients, fabulous. So what is the coefficient of the numerator? 1.
So equals 1.
Over 1, so it equals 1. The lead coefficient is always the coefficient of the term with the highest power.
Isn't that the limit too?
Well, that's the limit, but it's also helping us get the what? Horizontal asymptote. Fabulous. Y'all learned a little something, huh?
Y equals 1.
And I heard it in the proper form. What is it?
Y equals 1.
Thank you so much for not just saying 1. You said y equals 1.
I
Fabulous.
said Y equals 1. What is that?
Chance hands. Fabulous.
I think we had to do the. Oh, you're.
She said we need to do algebra aerobics because you won't stay up with us. Do we need to do algebra aerobics for you? Can you stay up with us? Are you feeling sick today? She's not talking at all. I'll let you make it for now, but we want to talk. All right, can we get the one just below that? Se nueve.
Okay, that's 1, 9. I go down more than 9. 9.
Yes, go more.
Okay, 9.
All right, let's see. Number 9, you've got natural log of x over 3x to the 5th. And what are we doing? Part A and part B? Okay. So for part A, we're doing the limit. This is number 9. All right, do we have a degree on that top one? No, but it's a natural log. Even if we don't know the degree, do we know how fast the functions grow? Which one grows faster?
The bottom one does?
Why? What kind of function is the bottom?
Exponential?
Not quite.
Huh?
It's exponential when the variable is in the exponent. Is your variable in the exponent?
No.
So it's not an exponential, it's a polynomial. So the denominator is a polynomial and the numerator is a the numerator is a log. So which one gets bigger faster?
Poly.
The polynomial gets bigger faster than the logarithmic. So it is big where? Getting bigger at the bottom faster, so the whole thing then must be approaching what? 0. So if that is 0, then how do you answer part B?
The limit is 0.
Y equals 0.
Y equals 0 for part B. That help out? Did that help out with number 9?
Number 6 and 7, is it 4 and does not exist?
I can't see 6 and 7.
Let's go to 6, 7.
All right. 6 and 7.
I got 6.
Well, let's see. 6 and 7 for the limit. Oh, you can find the limit on 6.
But I put 4 because the top one does not exist. Wait.
Careful. You can never use a point to find the limit. Which piece of this is just a point?
Oh, the second one. 4.
It just says x equals 1. That gives me one value. So this part, when you look at it on the graph, is a point. You will never use a point for your limit. Ever. Never, ever, ever.
What about the top one?
Because, think about it. The limit is what you're approaching, right? Can I see what I'm approaching left and right?
No.
With just a point? No. This says use this graph for everything else that's not 1. This piece is just some graph with a hole in it. Can I get a limit from that piece?
From the first one?
Yeah, the first piece is just some graph with a hole in it.
Yeah, but I'll give you a limit.
That'll give me a limit. So when I have a question like this with one of them not equal to the other, what is the limit?
-2?
Yes. Can you find the limit for 7? Bless you.
I got
Bless you.
Bless you.
Why did you get do not exist?
Because I put the number 1 for both functions.
And what did you get?
4
And are you having an epiphany right now? Are you having an aha moment? Bless you. Yeah. You said you plugged 1 in both of them.
7.
And what did you get for 1 here when you plugged in? You got a.
7.
Oh, that's
Oh,
4.
4.
And what did you get when you plugged in 1 here?
That's 3.
7.
1 squared.
1 squared is
Oh,
times
4.
3.
4.
Yeah. So what's the limit?
4.
So we got 7 and 6 and 2 and hey. Let me get those, put your names on them, send them up.
Oh, me and Melanie?